In this video, we will go over some multiple choice questions from past AP Calculus exams which pertain to Semester 1. Number 1. The maximum acceleration attained on the interval between 0 and 3 by the particle whose velocity is given by this function is which of these? So we are looking for the maximum acceleration, and we are given the velocity formula. Well, if we want to maximize acceleration, first we need to find the acceleration function. Acceleration is the derivative of velocity. So let's go ahead and take the derivative of the velocity function using the power rule. So we will have 3t squared, and then 2 times negative 3 is negative 6. So that's negative 6t, and then plus 12. So this is the acceleration function. In order to maximize acceleration, we will actually need the derivative of acceleration. So doing the power rule again, we get 6t minus 6. A relative maximum will only occur when a prime is equal to 0 or when a prime is undefined. Since a prime is a polynomial, it is defined everywhere, so we don't have to worry about this option. But where is a prime equal to 0? Let's set 6t minus 6 equal to 0 and solve. Adding 6 to both sides, we get 6t is equal to 6. Dividing both sides by 6, we get t is equal to 1. This is called a critical number, and it is a possible time of the maximum acceleration. But what are the other possible times of maximum acceleration? We are asked to maximize the acceleration on the closed interval from 0 to 3. The endpoints of this interval are also possible times of maximum acceleration. So we will use these two endpoints and the critical number we just found to make what is called a candidate's test. This is called the candidate's test because we have found the 3 possible candidates for the times of the maximum acceleration. The beginning of the interval, the end of the interval, and the critical number that we found. All we need to do is evaluate the acceleration function at each one of these times and see what the maximum value is. So let's do it. A at 0 would be all of this. Of course, these terms go away and we are left with 12. So the acceleration at time 0 is 12. A at 1 would give us this. This is just 3 minus 6 plus 12, which is 9. What about A at 3? If you crank this out, you get 21. So this is the maximum value. That's why the answer to problem number 1 is D. Let's skip problem number 2 and move on to number 3. The radius of a circle is decreasing at a constant rate of 0.1 centimeters per second. In terms of the circumference, what is the rate of change of the area of the circle in square meters per second? As soon as I hear them talk about rate of change, I'm thinking, okay, this is going to be a related rates problem. And the first thing I like to do is write down any rates that I'm given, any rates that I'm trying to find, and any other facts that I'm given. So they mention that the radius is decreasing at a constant rate of 0.1 centimeters per second. So we are talking about the rate of change of the radius. So I'm going to call that dr dt, the rate of change of the radius. And we are told that is a constant 0.1 centimeters per second. Oh, one more thing. It is decreasing. So therefore, I should call it negative 0.1 centimeters per second. So I have that written down so far. They are asking us to find the rate of change of the area of the circle. So they are asking us to find dA dt. Also, notice that they want us to find the area in terms of the circumference C. So here's the one fact that we are given, and here's the quantity we are trying to find. Since we need to find the change in area with respect to time, let's start by writing the area formula. The area of a circle is pi r squared. To make the dA dt appear, we need to take the derivative of both sides with respect to t. So on the left side, that gives us the dA dt that we need. On the right-hand side, we're going to do the power rule, and really the chain rule. So the 2 is going to come to the front, so we have 2 pi r. But because these variables don't match, we have to multiply by the derivative of the inner function, which is dr dt. But remember that we are supposed to find dA dt in terms of circumference. And we know that circumference is 2 pi r. Notice that we have 2 pi r right here. So we can write circumference. Also, we know that dr dt is equal to negative 0.1 centimeters per second. So we can make that substitution as well. So the final answer is that dA dt equals negative 0.1 times the circumference. So that means the answer is B. Number 4. If base B of a triangle is increasing at a rate of 3 inches per minute, while its height is decreasing at a rate of 3 inches per minute, which of the following must be true about the area of the triangle? And then we have all of these choices, but let's look at a couple of them. Choice A is always increasing. Choice B, A is always decreasing. Choice C, A is decreasing only when B is less than H, and so on. I wanted to read a few of those because it's clear to me that it's all about the rate of change of A. So let's see what we can figure out about the rate of change of A. I am going to approach this like a related rates problem. So I'm going to write down any rates that we are given and any facts that we are given. So the base B is increasing at a rate of 3 inches per minute. So they are giving us the rate of change of B. So in other words, dB dt is increasing at a rate of 3 inches per minute. So that's positive. Because it's increasing, it's positive 3 inches per minute. Okay, so we have that written down. What else? We are told that the height h is decreasing at a rate of 3 inches per minute. In other words, dh dt is equal to negative 3 inches per minute. Let's write that down. So these are the two facts that we are given, the two rates that we have. We are being asked about the rate of change of the area, so we need to find out anything we can. So I'm just going to go ahead and write down find dA dt. It's likely that we won't be able to actually find it, but maybe we can find an expression for it that will help us answer the questions. We need a relationship that connects the quantities that we are studying. So we have a base, height, and area. Well, the area formula relates all of these quantities. The area of a triangle is 1/2 base times height. Let's take the derivative of both sides of the equation with respect to t so that we can get the dA dt going. On the left side, we have dA dt. On the right side, I have this constant in the front. I'm going to go ahead and leave the constant out front, and then I will go ahead and take the derivative of b times h using the product rule. So the first time through, I take the derivative of b. So that'll be db dt. And I leave the second factor of h alone. So I have db dt times h. And then I put a plus. The second time through, I leave the b factor alone. And I take the derivative of the h. So that'll be dh dt. So there's your product rule. We know both of the rates in this expression, so let's make those substitutions. So I have 1/2, dB dt is positive 3, so I have 3h plus. dH dt is negative 3, so in fact, rather than putting plus, I think I'll just put minus 3b. So this is my expression for dA dt. Just to make the answers more obvious, I think I will factor out this common factor of 3. So the GCF of 3 will end up in the numerator of the 2. So the 1/2 becomes 3 over 2, and I'm left with h minus b. So the various multiple choice options revolve around whether or not dA dt is increasing or decreasing. dA dt will be increasing if this is a positive number and decreasing if it's negative. So that depends on what's happening with h and b. If h is greater than b, then the rate will be increasing. All right, dA dt will be increasing. If h is less than b, right, then we have a smaller number minus a larger number. So if h is less than b, then this will be a negative value and dA dt will be decreasing. So let's see if that corresponds with any of the options. We can cross out the options that say that A is always doing something because it depends on whether h is bigger than b or whether b is greater than h. So we can cross out option A, we can cross out option B. And we can cross out option E, where A remains constant. All right, it clearly depends. So we're down to C and D. Both C and D are written in terms of A is decreasing. So let's talk about under what circumstances A will be decreasing. A will be decreasing when this value is negative. That will happen when h is less than b. And that's another way of saying that b is greater than h. So let's see, A is decreasing only when b is less than h. Nope, we want b to be greater than h. All right, so we can eliminate option C. That only leaves option D. Let's take a look. A is decreasing only when b is greater than h. Yes, that's what we were looking for, and the answer is D. Number 5. What are the coordinates of the inflection point on the graph of y equals the quantity x plus 1 times arctangent x? An inflection point is where the graph changes concavity. For example, if the graph changed from concave up to concave down, that would occur at a point of inflection. A long time ago, we memorized the graphical relationship between f, f prime, and f double prime. We know that a function f will be concave up if f double prime is positive, and concave down if f double prime is negative. For that reason, if we want to figure out where a function changes concavity, we are looking for the location where f double prime changes signs. So our strategy will be to find f double prime and then analyze and see where it changes signs. First, we need to find f prime. Well, I should say y prime. So y prime, let's do the product rule. We have this yellow function, times this blue function. The first time through, we will take the derivative of the yellow. The derivative of x plus 1 is just 1. This time through, we leave the arctangent part alone, and we put a plus. The second time through, we leave the yellow function alone, so I put x plus 1. And then we take the derivative of the blue. We have memorized, hopefully, that the derivative of arctangent is 1 over 1 plus x squared. All right, you just have to memorize that. I'm going to go ahead and put this x plus 1 factor in the numerator. That would be the same thing. That way I can do the quotient rule when I do y double prime. Now let's find y double prime, term by term. So the derivative of arctangent, as we just saw, is 1 over 1 plus x squared. Moving on to the second term, we're going to use the quotient rule. And I always say the little poem, low d high, less high d low. Draw the line and down below, the bottom squared will go. If you've been watching this channel for a while, you've heard that poem many times. But just in case you're new, here's what I mean. When I say low d high, low is just the denominator. So I'm going to put 1 plus x squared. D high means the derivative of the numerator, which is just 1. So that's low d high. Less means subtraction. Low d high less high d low. High is just the numerator. And then d low means the derivative of the denominator. The derivative of 1 plus x squared is 2x. Draw the line, and down below, the bottom squared will go. So 1 plus x squared squared. I need to simplify this expression in order to find the location of the sign changes. But first, I got rid of the 1 and I moved the 2x to the front. So now I'm just going to do the distributive property right here with my negative 2x. And I can just get rid of the parentheses right here. So now I have this. We have like terms of positive x squared and negative 2x squared. So let's put those together. So now we have this. I really need to combine these into one big fraction, but I will need like denominators to accomplish that. The denominators are almost the same, but on the right-hand side I have 2 factors of 1 plus x squared. So that means I need to multiply by an extra factor of 1 plus x squared in the numerator and the denominator. So now I have my common denominator of 1 plus x squared squared, and I'm going to put the 2 numerators together. So from the left-hand side, I have 1 plus x squared, and then from the right-hand side, I have minus x squared minus 2x plus 1. I see like terms here and here. These will cancel out. And I see the 1 plus 1, which will make a 2. Let's not lose sight of what we are doing. We are looking for the point of inflection. That can only happen when y double prime changes signs. And y double prime will only change signs when it is either equal to 0 or when it is undefined. This fraction will only equal 0 when the numerator is equal to 0. So that means negative 2x plus 2 is equal to 0. Subtracting 2 and dividing by negative 2 gives me x equals 1. So this is one possible location of a point of inflection. This fraction will only be undefined if the denominator is equal to 0. And that will only happen if the stuff that's being squared is 0. So I can skip straight to 1 plus x squared is equal to 0. We can quickly see that this equation has no solution. If you square something, you get a positive value. If you add 1 to it, you get still a positive value. There's no way you're going to get 0. So x equals 1 is the only possible location of a point of inflection. Let's look back at our options. So I see a negative 1, 0, 0, and then the last two. We have 1 comma pi over 4 or 1 comma pi over 2. So the answer will either be D or E. Let's just find the y value. And we can find the y value by substituting 1 into the original equation. So in other words, we have y equals, well, if I put a 1 right here, this will be 2. So I'm just going to go ahead and put 2. Arctangent of 1. When you evaluate arctangent of 1, you ask yourself the question, the tangent of what angle is equal to 1? And the answer to that would be pi over 4. So that means the value of this part right here is going to be pi over 4. Wait, I just put 4. So this part is pi over 4. But we have pi over 4 times 2. All right, we have 2 times pi over 4. And then that makes pi over 2 when you reduce these. So that means that the actual y value is pi over 2, and the answer is E. Number 6. What is the minimum value of f of x equals x times natural log x? To find the minimum value, we're going to need the derivative. We're going to do the product rule. So the first time through, we take the derivative of the first factor, which is 1, and we leave the second factor alone. So I have 1 times natural log x, and I put a plus. The second time through, I leave the first factor alone, and I take the derivative of the second factor. The derivative of natural log x is 1 over x. Since x times 1 over x is just x over x, that is 1. And we have f prime equals natural log x plus 1. A minimum value can only occur when f prime is equal to 0 or when f prime is undefined. So let's start with setting f prime equal to 0. Natural log x plus 1 is equal to 0. That would mean that natural log x is equal to negative 1. Exponentiating both sides of the equation, the base e and the natural log cancel each other out, and we just get x equals e to the negative 1 power, which is the same thing as 1 over e. So this is one possible location of the minimum value. I'll come back to that. Let's talk about where f prime would be undefined. Well, natural log is undefined at 0. So that means that x equals 0 is a possible value where the minimum could occur. Well, except for one thing. Looking back at the original function has natural log x as part of it. So x equals 0 is not an option for the location of the minimum value because the original function is not defined at 0. So we can throw that out. Let's use the second derivative test to check and see if 1 over e is the location of a max or a min. F double prime of x will equal, the derivative of natural log is 1 over x, and the derivative of a constant is 0. So this is f double prime. So let's check out f double prime at 1 over e and see what we get. Well, this will be 1 over e. Multiplying by the reciprocal, f double prime at 1 over e is equal to e. What's important is that this is a positive value, right? This is greater than 0. That means that the original function is concave up in an interval containing this value, which means that this is a minimum. Okay, the original function will have a minimum value at 1 over e. Be careful. The question is not asking where the minimum value is. The question is asking what is the minimum value. We have determined that there is a minimum value at x equals 1 over e. If you want to know what the minimum value is, you have to evaluate the original function at 1 over e. So let's check it out. What is f at 1 over e? Well, that would be, all right, so I see the x right there, so that'll be 1 over e. And then I have natural log of x. So that'll be natural log of 1 over e. And I think I will go ahead and write 1 over e as e to the negative 1 power. So guess what? Natural log and base e cancel each other out. So these cancel each other out, just leaving behind the negative 1. So that's why the answer is going to be 1 over e times negative 1, or simply negative 1 over e. That's why the answer is C. Last one, number 7. What is the limit as h approaches 0 of this expression? Well, this limit reminds me very much of the traditional definition of derivative. The traditional definition of derivative, f prime at c, is this: the limit as h approaches 0 of f at c plus h minus f at c all over h. If you compare that to the limit that we were given, you can see how things sort of match up. Let's focus on the last term in the numerator in both versions. You can see that if this limit is indeed a derivative, then the function f of x must be 8x to the 8th power. And the c value must be this 1/2 that's on the inside. Let's see how it matches up with the rest of the definition of derivative. The first term in the numerator should be f at c plus h. And then sure enough, we see this 8 and then something to the 8th power. So that is function f. And inside we have 1/2 plus h. That is c plus h, if c is 1/2 as we guessed. So everything matches up, which means that this is indeed, this whole limit really means f prime at c, where f is this and c is this. So the quickest way to evaluate this limit would be to evaluate f prime at c using our derivative rules. So let's start by finding f prime at x. Using the power rule, 8 times 8 is 64. So that's 64x to the 7th power. And then f prime at c means f prime at 1/2. So this would be 64 times 1/2 to the 7th power. 1/2 to the 7th power is 1 over 128. And then this is just 64 over 128, which is 1/2. So the answer is B. Here is another way you could have solved the problem, and I'll let you decide which way you prefer. Since the numerator and denominator are both approaching 0 as h approaches 0, we are allowed to use L'Hopital's rule, which says that we can take the derivative of the numerator and denominator without changing the limit. I am taking the derivative with respect to h. So the derivative of the denominator is 1, and we will have to use the chain rule for this first part. So the derivative of the outer function, 8 times 8 is 64. You reduce this by 1, so that's 7. And we have the 1/2 plus h for now. And then we multiply by the derivative of the inner part. But the derivative of 1/2 is 0, and the derivative of h is 1. So I would just be multiplying by 1. And then this entire yellow part is a constant. So the derivative of this is just 0. But this is a limit that we can evaluate by direct substitution. All we really have left is this part right here, okay, because we have a 1 that we don't need and a 0 that we don't need to write. So we really just have 64 times 1/2 plus 0, all right, direct substitution, to the 7th power. In fact, since h is 0, we just have 64 times 1/2 to the 7th power. This should be looking pretty familiar right now. I'm going to put this down here. So this is going to be 64 times 1 over 128, just like we had before, and this simplifies to 1/2. So either way, you're going to get the answer is B.